All right, this is 11.2 in the green book. We are simplifying square roots. All right, so when x is equal to 3, if given an equation like this, and I substituted 3 in, isn't it true that we have to substitute, when I substitute for x, it doesn't matter where x is, I'm always substituting 3. Right? Mm-hmm. And 3 squared, I do the operation inside, I get 9, square root of 9. And we know that if this is 3, it's still going to be 3. And what is the square root of 9? 3. So is this a true statement, 3 is equal to 3?
Yes.
Okay? When x is a negative number in that same equation, let's look at it. We take negative 3 squared is what? 9. And if I'm substituting x for negative 3, it's staying that. And what is the square root of 9? 3. Is this a true statement? No. So we have to account for these negative numbers that we might input. Does that make sense?
Yes.
So the square root of x squared equals x only for non-negative values of x only. So if x happens to be a negative number, here's what we do. We have to set it equal to the absolute value of x. Okay? So if x is a negative number, we've got to set it equal to the absolute value of x. Now, if x is a negative number, let's try substituting it in. Negative 3 squared, right? And negative 3. So negative 3 squared is what? 9. Now, and the absolute value of negative 3 is what?
3.
Positive 3. So, the square root of 9 is 3, and this is how we get negative numbers to work. Okay? You guys clear on that? It's going to be kind of confusing in the beginning, and I'm promising you will get it by the end. Do you want to move up, Ariel?
I just wanted to see that last little red part.
It says the absolute value of x squared equals x for non-negative values of x only. So one more time, when x is negative, if I set this equation up and set it equal to just x, it doesn't work with negative numbers. So to account for the negative, I have to set it equal to the absolute value of x. You with me?
Oh, so you're just substituting negative 3 into x squared. So I didn't.
To x squared and x.
Yes, I didn't see what you were doing.
For anytime I see x, I'm substituting negative 3.
Then that's where the absolute value comes.
Right, because we know that in the general equation, if it's a negative number, you've got to set it equal to this.
All right.
So now we said this. We said the square root of x squared is equal to what?
X to the absolute value.
Absolute value of x. Say the absolute value of x.
Absolute value of x.
Okay? Because this way, if it's positive or negative, it will be handled. The negative. Okay? You should be writing this down. Okay, now, if I have x to the third, let's talk about what that really means. That means this. X times x times x. And can I split that up and say x squared and x? Yeah? Okay, now remember what I said, like if I have 9 squared, okay, 9 squared really equals what inside?
81.
And the square root of 81? So do you notice that when you have a square and a radical, they negate each other? Are you seeing that?
Yeah.
So in this case, what is the value of just this?
X.
That's x. And then I'm left with this. Is that safe to say?
Yeah.
So we said x cubed equals the radical x times radical x times radical x. And we can take 2 of those x's and make an x squared. You guys with me? And what's the square root of x squared? X. And then I'm left with a radical x. You with me? Okay, so that's the value there. Now, let's keep going and keep following this pattern. So we said it equals that. X to the 4th. X to the 4th. What do you think that's equal to? Look at how many ways I can write this. Okay, Kyle?
I think if you're just trying to find x to the 4th,
What?
it would the square root, it would be x squared.
X squared.
Yeah.
That's it. X squared because, whoops, because the square root of x squared is x and x. So what's the pattern there with even numbers? What's the pattern?
With the even exponent?
Yeah. Yeah.
Would it be half?
Yeah. We're halving them. Okay, so now we've got x to the 5th. So really inside that radical, x, 2, 3, 4, 5. And what's left? Yes.
I think we could do x squared and x squared. Or, no, and like
It doesn't matter. We can put it all under. What's the square root of that?
X, and then that would be x, that would be x, and then that would be square root or x. Yeah.
Yes. And so what's my final answer?
That would be x squared plus the in square root. X.
Yes. And we call that symbol a radical. Radical x. Or rad x. As my son says. He says rad x. Okay. This symbol right here is called a radical. And the number that goes inside is the radicand. And it's spelled radicand. Okay? All right. X to the 6th. Jonah?
I'm going to say that the square root of x to the 6 is x to the x cubed.
X cubed. But now, remember what I said? What happens if that x cubed is a negative number? A square root can't equal a negative. So what do I have to do?
In the absolute value.
Yes. I'm putting it in the absolute value. Okay, next one. X to the 7th. Can't we just say that x to the 7th is really made up of x to the 6th times x? You guys with me? Right? So what's the square root of x to the 6th?
I mean, x cubed.
X cubed. And then I'm left with radical x. Okay? X to the 8th. Ariel?
X to the 8th could be x to the 4th times x squared. Or no, x to the 6th times x squared.
Okay, let's just do this. When you have, I've got 1, 2, 3, 4, 5, 6, 7, 8, all under the radical.
Okay.
And we said every 2 make up an x squared, right? So what's the square root of that?
Oh, I wasn't saying the final. Okay. X,
That,
X,
that,
X,
and that. And so what is the answer? X times x times x times x? Huh?
X to the power
x to the fourth power.
I wasn't saying the final answer when I said that. I was
Oh.
just saying, like,
You were just breaking it down. Okay, so one more time. What is the pattern here with these even numbers?
It's a half.
It's half. Notice here it's half, and here it's half. And here it's half. And here it's half.
Oh,
Okay, x to the ninth. Yes.
X to the fourth, radical x.
Perfect. Because isn't it x to the eighth times x? Go to the closest even number down. We go to the closest even number down. And that would be x to the eighth. The square root of x to the eighth is x to the fourth. And I'm left with one more. Yes.
I mean, I don't know if this is like something, but like every odd, well, like for every one of the odd exponents, the exponent outside of the radical is just increasing by 1.
Okay. What else? We have more. Ethan?
You had a question. For when you do x squared, why is it the absolute value for that and the x to the 6th power, but not like x to the 8th power or x to the 4th power?
Well, because if I have a negative number here, isn't it going to get handled here? Because negative times negative makes a positive, and my results are negative. So you tell me, why am I putting it here and here, but not here and here?
I have a question.
Nicholas?
because, like, the odd ones, if you have a negative number, it'll just stay negative, but you need to be positive, so it's absolute value.
Right. So when is it absolute value? When do we use that absolute value symbol? Yes.
When you have an odd number.
When you have an odd result and nothing else next to it. Now I have an odd result here, but if this is negative and x is 7, if this one's negative, we've got one more result right there. Is that making sense? If this is negative, I've got something else to multiply it by. It will handle the negative issue. But here, when it's just an odd result and nothing else next to it, we've got to put it in the absolute value. So what would the next one be, please? Yeah.
I have a question on that. So say the x in the x to the 7th, the separate part, not x cubed, but the other part. What if that one turns out to be, or it could be negative and positive, right?
Because if x is the same thing, if x is negative, it's going to be negative here and here. X isn't changing values. It's the same value. Okay, yes.
Just, would it be wrong to say that like radical x to the fourth, like to put like x squared in absolute value? Like
Yes, it would be wrong because you don't need to. The negative is handled because a negative times a negative makes a positive.
Right.
It doesn't matter. Whatever x is, if it's a negative number, it can be negative because it will be multiplied by itself 4 times.
Yeah,
Yes.
I want to solve the next
The next one, Victor.
the absolute value of x to the 5th.
Yes. So the next one. Clover.
I have a question. For the radical x to the 5th power, wouldn't the result be like in absolute value?
Radical x. This one right here?
Yeah.
Wouldn't the result? No, because if x is negative, as long as there's something else next to it, it will be taken care of. Okay? It's only when an odd result is left alone. Yes.
So when we get these problems like on the test,
Don't worry about that now. Let's get the pattern. Okay? What's next? Camilla.
yeah, it'd be x to the 5th times radical x.
X to the 5th times radical x. Good. Because the closest even is x to the 10th. That's x to the 5th. And then I'm left with one more x. Lily, are you clear? Next one, x to the 12th. Maya.
X to the 6th.
Good. Next one, x to the 13th. Tyler?
X to the 6th times radical x.
Good. Okay, you guys get the pattern? Now, go. You're doing the next few. Pause the recording. All right, let's check our work. Now, x to the 23rd. What is that, please? Jagger?
X to the 11th and radical x.
Good. X to the 24th. Ethan Binns?
X to the 12th power.
Good. Jonah?
X to the 25th is x to the 12th radical times
Good.
radical.
Okay, now, radical x to the 50th. Jonah?
Radical, no, x to the 9th, no, x to the 25th.
Okay, x to the 25th, but it's an odd result, so we need that absolute value. What about number 2? Ani?
X to the 42.
42. We half our even numbers. Now, how about Lily?
Would it be x to the 10th radical x?
Well, every time, what am I doing with the 84? We do what? Right, and half of 100 is what? No, half of 100 is not 10. Huh? So what is it going to be?
X to the 50th.
Yep. So notice, we're going to the closest even number, going down to the closest even number. That would be x to the 100th. I take the square root of that, and I'm left with one radical. Tyler?
So we're going to have 51.
Good.
X to the 51st times radical x.
Perfect. So 102, half of that. Okay, next one. Michael? So I'm going to, one more time, I'm going to explain. We break it down to the evens. X to the 100th. The closest even number underneath times radical x. And what's the square root of x to the 100th? So it'd be x to the 50th. And I'm left with radical x. You're doing the same thing here. It breaks down to what too? What's the closest even number? X to the what? Closest even number. Yep. 2. Yep, and the square root of that is 2. 1, 25, 26. Is that making sense? Yep. Next one, Michael. This should be an easy one. Shh. No. Half.
Oh yeah, 241.
Yep. You guys get the idea?
Absolute value of x.
Absolute value because it was an odd result. You're right. I'm wrong. Okay? Now, the next part of the homework for tonight is stating the domain. Okay? We just finished with the domain in fractions that said thou shalt not divide by 0. Our new domain is, we've been talking about, we've been talking about our real numbers, rational and irrational, remember? We've got all of our rationals, all of our irrationals, and then we have our imaginaries. According to this rule, for the domain, what is x allowed to be? It's not allowed to be for a radical. It can't be negative inside there because no number times itself will give you a negative. So x has to be an element of the reals, right? It's part of these numbers, part of the real number system, not the imaginaries. Am I right? And x is not allowed to be negative. So how could I show that? What numbers is it allowed to be, Ethan?
X is greater than or equal to 0.
Exactly said. Perfectly said. So x is part of the reals, and that is the big domain rule for radicals. It's always greater than or equal to 0. So when you have an equation like x plus 4, this one's easy. But any equation, we're going to set the rule for a radical is greater than or equal to 4. So I take the equation and I set it. Greater than or equal to 4. Every time, no matter how fancy. And then I subtract 4. X is greater than or equal to negative 4. And we list x is greater than or equal to negative 4. It has to be an element of the reals. And for it not to be negative in there, it can be negative 4 or bigger. Are you guys clear on that? All right. Next one. What would the answer be? How about Shane?
I got x is greater than or equal to 5.
And
Oh, x reals.
x is an element of the reals.
X is an element of reals. X is greater than or equal to 5.
Good. Now, these are going to get fancier. They're going to get fancier. So in this case, we do the same thing. 2x is greater than or equal to 0. When I set 2x, divide both sides by 2, what is x greater than or equal to? Everybody? Divide by 2. X is greater than or equal to 0. 0 divided by 2 is 0. It may even be a two-step. It may have fractions. Set it greater than or equal to 0. Because the domain for a radical is 0 or higher, is what it's allowed to be. Am I clear? Subtract. So in this case, x is greater than or equal to 1/5.
You're just solving it, but you're setting
Yeah,
it
you're just
you're setting it to be greater than or equal to 0.
that is what you have to know, because nobody's going to tell you that here in the directions. That's your domain rule for radicals. Yes, Cami.
Is there any time where we won't do the x is an element of the real?
No, you usually say. Okay, so then we're going to be evaluating, and they're going to ask you, is it a real number? When I substitute it in and I get something like this, is it a real number?
Yeah.
Huh? Is it part of one of these two groups?
Yeah.
Yes, that's a real number. Okay, what about this one?
Yes. Yes, that's a real
100%
number.
it's a real number. What about this one?
No.
That's where we would say it's not an element of the reals. Okay? Yes?
So whenever we write our domain, would we always write it has to be a part of the element of the real?
Yes. Yes. Do you have a question, Ariel?
Yeah, kind of. I understand. I'm trying to understand why it wouldn't be written. Basically, are you saying because that doesn't equal the same thing?
You can't take the square root of a negative.
Oh,
No number times itself will give you a negative. So when you get set into that situation, remember, the domain states it has to be 0 or greater. You can't take the square root of a negative. You're going to say no real root. All right, now, finally, okay, really quickly, when I'm left with something like this, I'm just showing you this end part, negative 3 plus or minus, I simplify in there. Okay, negative 3 plus or minus the square root of 25. What is the square root of 25? 5. Negative 3 plus 5 is what? It's just two equations.
Yeah, it's 2.
Negative 3 plus 5 and negative 3 minus 5.
So it would be 2 and negative 8.
Do you understand how to simplify this?
Yes.
Okay, now we're going to put it all together. Okay, if I have a perfect square trinomial, not yet am I putting it all together. If I have a perfect square trinomial, or okay, remember what we said. When I take the square root of, do you remember what we said here? If I'm taking these two, whenever I have the square root of x squared, I have to write the absolute value. Well, I've got the square root and squared. So what do you think the answer is? The absolute value of n plus 1. Are you with me? Because it's an odd result.
Would it be, what would make it even? I'm a little confused on what defines.
If I had x to the 4th here,
Okay. Oh.
I mean, if I had to the 4th power, it would be an even result. But since I'm taking the square root and it's to the 1st power,
This one's only the first power.
right.
Yes. Okay.
So what's this one going to be?
Oh, number 1, x minus 4 to the first absolute value.
Absolute value of x minus 4. Next one, number 2, raising a quiet hand, Maddie. Quiet. Ani?
Absolute value of 2x plus
Maddie. Thank you. What?
absolute value of 2x plus 3.
Good. Next one, Maddie.
Absolute value of y minus 5.
Good. Now, this one's a little bit different. Why? Cammy?
You still have to factor it.
Okay.
Once you factor it, you get x minus 3 squared, which then it becomes the absolute value of x minus 3.
So you guys clear on that? Okay. Lily? Okay, same thing here. Okay, now we're going to actually use it. So, in the past, okay, I need you to stick with me through this because I think I can get through it pretty quick. In the past, we've been solving equations with the zero product property. Move everything to one side, set it equal to 0. Okay, well, this is called the square root method. We can do anything to an equation as long as we do it to both sides. Now, for the moment, you are going to pretend that's not there. Sorry, pretend it's not there. Okay? What is the value of the square root of x squared?
X?
No.
Oh, absolute.
And the square root of, good. And the square root of 9 is 3. So now, to lose that absolute value, what are the values that could be? Negative 3 and positive 3 would make that. So to lose the absolute value sign, I just say x is equal to plus or minus 3. Okay? That is called the square root method. Your whole algebra career will soon all come to an understanding in chapter 13. Okay? So we have 2 solutions here that work. Okay? Now, what would I do to solve that? Yep.
Find the square root of both.
Find the square root of both sides.
X is 6.
What do I get?
The absolute
Value of x.
Equals 6. Plus or minus x equals plus or minus 6. Okay? Doing the same thing here. When I get something like this, an irrational number.
Oh, you have to do that.
Hold on. So I'm taking the absolute value. Now look what I do. Because irrational numbers go on and on forever. If it's irrational, a non-perfect square, leave it in the radical. It's way more accurate in radical form. To lose the absolute value, I do plus or minus radical 7. You should write that one down. Do you understand? Yes or no?
Yes.
Who said no? Okay, what am I going to do here? I don't get to use the square root method until the square is alone. Jared?
You're going to solve it as a 2-step, so you're going to add 6 to both sides.
And then?
And then you can use your square root method and then you can leave it.
What do I get?
You would get the absolute value of m
Equals
radical 13, and then you could simplify that to m is equal to plus or minus radical 13.
Please do not skip this step. I want to see this in your line of logic. Okay? Now they're going to get bigger.
Ooh.
Isolate your variable. Add 20. Divide by 3. Take the square root. Absolute value of y equals 4. Y equals plus or minus 4. Okay?
Oh,
You guys get it? Wait, I'm going to keep going.
We have a quick.
Let me keep going because the bell's going to ring.
GCF there?
What?
Just quickly, would you pull out a GCF?
We don't need to. We're not factoring. We're using a whole nother method.
Okay.
We're solving to get the variable alone. Okay, he wanted to GCF. I've embedded this so much in your brain. All you want to do is factor, factor, factor. Factoring is one way to solve a quadratic. There's going to be many ways, but it's one way. This is number 2 ways. And when I teach you the quadratic formula, you won't go back to that other stuff. That's why I don't teach that in the beginning, because you won't learn the other stuff. It's very easy. Okay, they're just going to get a little bit longer. Oh, when we get here, subtract 30. You guys with me? Divide by 2. I get y squared. Take the square root. Look what situation I'm in. I can't take the square root of a negative. Right? So we would say no real root. And what do I mean by no real root? No, what I mean, there's no number in this system. That's what we mean, because these are our real number systems. Rationals or irrationals. Okay. I'm going to just keep going. Let me see. Let me throw you. What do I do now? What am I doing now? Same thing. The square is isolated, so what do I do?
You're going to use your square root method, square them both. And then you get
Take the root of both.
Or take the root of both, yeah. And then you would end up with absolute value y plus 1 is equal to 4.
Equals 4.
And then you can get rid of the...
How do I lose the absolute value?
You add the plus or minus, so y plus
Set it
1 is equal to plus or minus 4.
And that means what? Y plus what?
Y equals 5.
No, not y. Y plus 1 equals positive 4, or y plus 1 equals minus 4. Or we can just subtract 1
Okay.
first. Negative 1 plus or minus 4. Negative 1 plus 4, negative 1 minus 4.
But would either be, would you have to simplify it to that?
Yes.
Okay, so
You have to go all the way.
so that's a definite.
Yes. Get your y alone, then set it, then break into your 2 equations. Yes.
If you wanted to, could you do y plus 1 equals 4 and then y plus 1 equals negative 4 and then...
Yeah, that's fine. But, I mean, I just like the inverse operations. Okay, try the next one, guys. Go. Okay, let's check our work. Okay, you guys, everybody clear?
Yep.